So this question here is a systems of equations question, right? It's a word problem. So my first struggle here is going to be having to write out the two equations to model my system before I even worry about solving the system. Okay, so let's read through it together first. It says Lydia wants to take art classes. She compares the cost at two art centers. Center A charges $25 per hour and a registration fee of $25. Center B charges $15 per hour and a registration fee of $75. Lydia plans to take X hours of classes. So there's a lot of information there. Okay. But the first thing I want to do is I want to write an equation that models situation A. Okay. Is how much is it going to cost for situation A? So let's go back to the text. Okay. Now I can see here, center A, okay, they charge $25 per hour and they have a registration fee of $25. Okay. So this here is like a classic slope intercept form. Okay. This $25 per hour is my slope. This registration fee is my y-intercept. So I know that situation A is going to look like 25x. And again, note, x here was the number of hours. So that checks out. Okay. Plus that registration fee of 25. Okay. And again, the main thing here is I'm recognizing that this is linear, it's slope intercept form. Okay. So that's kind of how I know what the structure of this is going to look like. Now, situation B is going to mirror that. Okay. Is my second equation here for center B. It's 15 per hour. Again, that 15 there that's essentially my slope. Okay. The 75, that's my y-intercept. So it's going to take the same structure as this one did. That one is now going to look like B is equal to what I got here. My slope again was 15 times x plus 75. Okay, that's my first part. Now, this is a 6-point question on the Regents, so I get 1 point for getting each of these equations down, right? Now, next part. If Lydia wants to take 10 hours of classes, use my equations to determine which center will cost less. Okay, now this part itself is fairly straightforward. Okay, is all I need to do now is take these values here, okay, this value of 10 specifically, and substitute it here, and check which one costs less money. Okay, that's literally all it's asking me for here. Okay, so let's start with center A. Okay, as I know this here is 25 multiplied by 10 plus another 25. Okay, now these numbers are easy enough that I can just do this by hand, but you can also feel free to throw this into a calculator at this point. Okay, I know 25 times 10 is 250, plus another 25 is I know that this here is going to cost her $275. Okay, now same thing as let's go on to center B. Okay, so center B, again, this here, 15. Whoops. I wanted to use blue for that. And I lost my blue. There she is. Okay, so for center B, it's going to be that $15 per hour multiplied by the number of hours, which like the last one was 10. And then I'm going to add on $75. So the main thing here is attention to detail. Okay, is make sure that you're not mixing up the numbers from the different equations. Okay, so again, I can stick this into a calculator. 15 times 10 though is 150. 150 plus 75 is going to get me to $225. Okay, so right away here, I know the answer is center B. But let's make sure that we write that here. Okay, so center B will cost less. And my proof for that is right up top here. Okay, so now this specific question here has one more section. Notice I haven't actually solved the system yet. Okay, some questions will ask you to solve them algebraically. This specific question here is going to actually ask us for a graphical solution to it. Okay, so I'm going to turn the page here. Okay, and it's going to ask me to graph the system out. Okay, so I'm going to first rewrite my equations over here on the left-hand side so that I have them. So that was y is equal to, I believe it was 25x plus 25. And my second equation was y is equal to 15x plus 75. So at this point here, it's easy enough to graph this by hand if you do recall your slope-intercept form, okay? And how to use those points. But I'm going to show you guys two different ways to do this, okay? Is for the first one here, I'll graph this by hand, okay? And the second one, I'll walk you through how I could actually use a calculator to graph this, okay? So let's start off with this first one here, okay? Is 25x plus 25, right? I've got my x-axis here, I've got my y-axis. So 25 is my y-intercept, okay? That means that I'm going to start off on the y-axis at a value of 25, which is right here in between 20 and 30. Now, next is I'm going to use my slope. Now, remember, when we think about slope, we think about rise over run. Okay, so in this case here, 25 over 1 is my rise over my run. Okay, now what that means is that I need to go up 25 for every time I move to the right one. Now, note, ours is counted by ones. This here seems to be counting by fives, right? If I say 5, 10, 15, 20, 25, okay. So I know I'm going to go up 25 and right 1. So from this point here, my y-intercept, I'm going to have to go up 5, 10, 15, 20, 25, right 1, plot a point. Remember, slope are just instructions on how to plot your points. Next, up 1, 2, 3, 4, 5, right 1, and just use that recipe again. 1, 2, 3, 4, 5, right 1, 1, 2, 3, 4, 5, right 1. Let me just double count that. 1, 2, 3. Yep, that's right. Again, 1, 2, 3, 4, 5, right 1, 1, 2, 3, 4, 5, right 1, and so on. Okay, now at this point here, I would grab a straight edge. I'm going to do my best here to make a straight line. Okay. On your end, you would be using a ruler and trying to get this as straight as you can. Okay. So that's my first equation here. Okay. Y is equal to 25x plus 25. Now when I graph by hands, slope, y-intercept. Okay. But the great thing about the Regents exam is that you guys have graphing calculators. Okay. So that's a powerful tool that we can use to help us when it comes time to graphing something. Okay. So what I can do is take this equation here, y equals 15x plus 75, and dump it into my actual graphing calculator. So I'm going to do that here, okay? Because I'm going to go over to my calculator, hit y equals, I've got 15x plus 75. Now graph. Well, that's not super helpful, is it? So instead of looking at the graph, let's look at the table, okay? Now, what does the table do is it actually shows me what those x and y values are. So when x is 0, y is 75, okay? Which I can also see from here, right? That's my y-intercept. So 0, 70, 75 is my first point. Now, when x is 1, y is 90, okay? So I'm over at 1, and I'm going up to 90. Here's my next point, okay? When x is 2, 105. Okay. When x is 2, I'm at 100. Where'd we go? 105 is here. Okay. When x is 3, 120. 3, I'm over at 120. Looks like I'm getting closer. Okay. 4, 135. 435 almost. Okay. And then at 5, I'm at 150. 5, 150, which appears to be my intersection point. Okay. Now, I know this is going to be my answer here. I can continue this. What I also notice is that, right, this is going up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Up 1, 2, 3, right 1. So once you kind of have 1, 2, 3, okay, a couple of points down, you'll see the pattern, and that you can use to continue plotting your points, right? And again, your line hopefully is straighter than mine, okay? But the fact that I plotted out all these individual points makes it a lot easier for me to identify the solution. Okay. Is sometimes what I see students do is only plot, say, 2 points and then use a ruler to draw a line. 2 points, use a rule to draw a line. In a case like this here, it might be hard to see where that actual intersection, where that solution lives. Okay. But I can see this here is my solution. Now let's actually see what the question was. State the number of hours of classes when the centers will cost the same. So I can tell my actual solution here is at 5, 150. Okay, but this isn't actually asking us for the entire solution. All it wants is the number of hours. Okay, so the number of hours here is down here. That's my X coordinate. Is this here is going to end up being 5 hours, where both of them end up having a cost of $150. But the main thing is to make sure that you are actually answering the specific question that is given. Okay. But that is a fairly straightforward system of equations. And again, we happen to solve that one graphically because that is what was asked for in this specific question.